Okay, athletes, what we're going to look at in this video is acceleration. So we've already looked at position, we've already looked at velocity. So acceleration is just a tiny little step forward. Um, you're not going to find, if you understood position and velocity, acceleration, it goes hand in hand. So you'll be okay here. So just make sure that you've gone back and mastered velocity before you do acceleration. Kind of makes sense. So the position of a particle moving on a line is s at t, and here's a cubic function where displacement is measured in meters and seconds. And what we're going to do here in A is we're going to find the velocity and the acceleration. So just remember that velocity is the derivative, it's the instantaneous rate of change of our position function with respect to t. So we take the derivative like that. And then our acceleration is the instantaneous rate of change of velocity at that moment. Or you could think of it as the double derivative of the position, and that gives us this beast. Okay, so there's A done. And B says find the acceleration after 20 seconds. Okay, well, the acceleration at 20 seconds. So all we do then is we let time be 20. And what's that going to give us? 240, that's 250 meters per second squared. Okay, just like that. So again, what you're saying here is you're going, these questions actually aren't that difficult. If you've really mastered the idea of what velocity and is in the first place, then acceleration is going to be okay as well. Okay, I just want to talk maybe about one more quick question here that I don't have written down, but a lot of you have probably taken some physics, right? And so even back in other classes that we've taken, we get projectile motion is a big one. So I'm throwing something like a football like this, right? And you remember doing questions like this, and where's the max and where's the min? And you did those all in a different class, maybe by completing the square. So let's just say I've got some position function. And if you've ever wondered why when you were doing these position functions, a lot of the time on something like this, it says the height with respect to time, it's a parabola. And if you ever remember back, a lot of times you saw 4.9, negative 4.9 in the question. And it was something like this. And then the constant, like wherever I launched it from or whatever, who knows, plus 10t plus 6, who cares? I don't really care about this. So this is our position function, right? It's actually, sorry, I should call this our velocity function here. So when we go to take the height, when we go to take the derivative of this, we get the velocity. That's our position function. When we take the derivative of that, we get 9.8t. Now I'm thinking if you're in physics class, that's starting to sound familiar, right? What we know is, what's this? This is acceleration due to gravity, isn't it? So if we take the derivative of that, we get negative 9.8. Like, do you see it? That's gravity right there. Okay, so you start to see these links between position to velocity to acceleration, and you start to see where gravity comes in. I know some of you are saying it's negative 9.81. I know. This up here then should be, I believe, that. So there it is. There's a link between position, velocity, and you see where that gravity number. Why do we always see negative 4.9? Because it's linked to gravity. Okay, I thought I'd just ramble for a second. See you later, friends.